In this session, we will discuss the stock removal cycle. In the previous sessions, we discussed the OD roughing stock removal cycle machining program. Now, we will use same stock removal cycle for ID profile roughing program. Let's start the discussion of the stock removal cycle. This is the raw material. In this raw material, we need to create this type of component. For this component creation purpose, we have to do three types of programs. The first one is drilling, second one is ID roughing, and third one is ID finishing. Why drilling is required to do before doing ID profile? For selected ID profile, selected tool will look like this. This can't perform without any hole. So for creating hole we need to choose drilling operation. Let's start discussion on drilling operation for selected drawing. In this drawing, minimum hole diameter need to check. For selecting the required tool diameter, for drilling, that is 20. So our drilling tool must be 20 or below 20 should be selected. This is our WCS for drilling operation. Here, X is 0 and Z is 0. Drilling, reaming and tapping operations must be done on X0 position, only in turning machine. Now let's see how to make drilling operation in controller. Select the machine and start the simulator. Next, adjust the speed override and feed override. The machine required a reference. Click on X plus and Z plus. Next, go to the program manager for new program creation purposes. Click on the new. First, we will create the main program. Write the program name is drill and ID cycle.mpf. Click on OK. The new file is opened. In this file, we write the program. Header G18, G90, G64, G71, G95. Next. G75, X0, Z0. Next. M06, T2, D1. Next. M03, S500. Next. G00, X105, Z20. Next. G00, X0. Next. G01, F0.2. Next. Drill cycle. That cycle is available in the drill option on the horizontal keys. Click on the drill. Go to vertical keys. These are the drilling cycles. We go to the deep hole drilling cycle. This is the cycle 83. These are the parameters available in this cycle. Now we will discuss them one by one. First one is RTP. It means retraction plane, value should be given in absolute. My retract value is 50 mm. Next, RFP. It means reference plane, value should be given in absolute. That is 0. Next, SDIS. It means safety distance, value doesn't need any sign indication, should be always positive. That is 1 mm. DP. It means final drilling depth in absolute. As per the component total length, 100 mm. Then we need to make hole more than length, because of drill angle, so total drill depth is minus 108 mm. DPR. It means final drilling depth relative to the reference plane. Value doesn't need any sign indication, should be always positive. Choose 0 or 108 mm. FDEP. It means first drilling depth in absolute. Minus 10 mm. FDPR. It means first drilling depth relative to the reference plane. Value doesn't need any sign indication, should be always positive. Choose 0 or 10 millimeters. Damn. It amount of digression, value doesn't need any sign indication, should be always positive. Keep it empty. DTB. It means dwell time at drilling depth, used for chip breakage. Dwell time can be mentioned in two values, like greater than 0 as in seconds, and less than 0 as in revolutions. DTS. It means for dwell time at starting point and for chip removal. FRF. It means feed rate, factor for the first drilling depth. Value doesn't need any sign indication, should be always positive. Range of values start from 0.001 to 1.000. Choose 1. Vary. It means machining types. 0 indicating chip breakage, and 1 is indicating chip removal. Choose 1. AXN. It means tool axis, 1 is indicating Z axis, 2 is indicating X axis, and 3 is indicating Y axis. Choose 1. MDEP. It means minimum drilling depth. Choose 5. VRT. It means variable retraction value for chip breakage. VRT can be mentioned in two values, like greater than 0 as in seconds, and less than 0 as in revolutions. Choose 1. DTD. It means dwell at final drilling depth. Choose 5 seconds. DIS1. It means programmable limit distance for reintersection in the drill hole. If you keep 0, then cycle itself automatically choose vary value. Click on the OK. Drill cycle added to the program. Next, footer. G00. Z5. Next. G75. X0. Z0. Next. M5. M9. End the program. M30. Go to the offset and check the tool. The drill tool is not available. Now, we create the new tool. Go to the new tool. Select the drilling tool. Give the tool number is 2. Select the edge position number 7. Click on OK. The tool is added to our tool list. The X value is -100. And Z is -100. We require a tool diameter is 20. Radius is 10. Next, go to the program. Now, go to the simulation. Activate the auto mode. Next, click on the cycle start. This is the tool path of our program. Let's move on to the drawing for internal turning profile discuss purpose. This is the R component drawing. First we will mention the points of the profile. Where our points are start. Our points start at major diameter. The major diameter point is P1. Next, to radius starts point. That point is P2. The radius endpoint is P3. Next, linear axis endpoint is P4. The taper endpoint is P5. Next, the linear axis endpoint is P6. The next point cross-axis endpoint is P7. Chamfer endpoint is P8. Then our last linear endpoint is P9. Now, we will discuss the values of these points. The P1 point value is X90, Z0. Next, P2 point value. In the P2 point diameter is same, X90, then Z value is -25. P3 point radius endpoint diameter value is X80, Z is -30. Here we need to mention CR equals 5, or I equals -5, K equals 0. P4 point values, X is same as previous value, and Z is -45. P5 point is a taper, then values are X50, Z is -65. P5 to P6 is a linear axis, then Z is -80. P6 to P7 is cross-axis, then x26. How to calculate this position already we discussed in previous sessions. P7 to P8 is taper, then values are x20, z is minus 83. Or instead of z minus 83 we can write chr equals 3. P8 to P9 is linear, then value x20, z is minus 100. The safety point value is x18. Now, we will add these points to the motion commands. The first point motion is linear motion with slow feed. That motion code as G01. From P1 to P2 is also linear motion, code as G01. From P2 to P3 is a circular motion in the anti-clockwise direction. That motion code as G03. From P3 to P4 is linear, then motion code as G01. From P4 to P5 is linear motion, then code as G01. From P5 to P6 is linear motion, then code as G01. From P6 to P7 is linear motion, then code as G01. From P7 to P8 is linear motion, then code as G01. From P8 to P9 is linear motion, then code as G01. Next, check the safety point of the workpiece. This is the safety point. The safety point value is x102, z2. These values are shaper values. Our program structure is a header, cycle, and footer. Next, move on to the software. This is the graphic display. Go to the edit. This is our main program. But before writing the stock removal cycle, we need to create a subprogram and write the shaper values. That's why, go to the program manager for subprogram creation purposes. Click on the new. We will write the subprogram name, idprofile.spf. Click on OK. The SPF file is opened. Here, write the shaper values. First value is G01, X90, Z0. Next, G01, X90, Z-25. Next, G03, X80, Z-30. CR equals 5. Next, G01, X80, Z-45. Next, G01, X50, Z-65. Next, G01, X50, Z-80. Next, G01, X26, Z-80. Next, G01, X20, Z-83. Next, G01, X20, Z-100. Next, G01, X18. Subprogram end code is M17. Next, go to the program manager. Go to the program list. Our main program name is drill and ID cycle. Select that program. Next, click on the enter. Main program is opened. In this program, go to the last block. Delete the M30. Because we will add the stock removal cycle here. Let's start the program now. Activate the tool here because our previous tool was a drilling tool. We cannot do ID turning with that tool. That's why we changed the tool. M06, T3, D1. Next, activate the spindle. G96, M03, S300. LIMS equals 2000. G00, X102, Z2. It is the safety point. Next, M08. Now go to the turn option. Click on the stock removal cycle. We already discussed these parameters in the previous session. In the NPP we will write the subprogram name, ID profile. Next, MID, it means depth of cut for each pass. Choose 1.5. Next, FAL, it means finishing allowance in both axes. Choose 0.2. Next FF1. It means feed rate for roughing. Choose 0.15. Next FF3. It means feed rate for finishing. Choose 0.1. Next vary. It means machining types. Choose 11. Because 11 is the ID rough and finishing operation. Next VRT. It means retraction path. Choose 2. Click on OK. Cycle is added. Next footer. G00. X102. Z2. Next G75. X0. Z0. Next M5. M9. Next M30. Now go to the offset for ID tool creation purposes. Click on the new tool. Go to the turning tool. The tool number is 3. Next, select the edge position number 2 for ID tool. Click on OK. The X value is -100. Z also -100. Tool nose radius is 0.8. Now, go to the program. Go to the stimulation. Add the raw material. Go to the More. Click on Material Removal. Add the raw material length and diameter. Length is 100 and diameter is 100. Click on Save. Adjust the material. Next, click on Cycle Start. Now, this is drilling. After drilling, ID turning starts. ID stock removal cycle is completed.